right, hello folks. We are on section 5.2, which is congruent triangles. Let me see where the top's at. Congruent triangles. And homework is page 301, 2 and 4 through 12. That is it. We are going to do number 4 together because it's a little bit longer than the other two. We'll do 4 together at the end, but let's go through the notes first. And here we go. Congruent triangles, 5.2. This starts on page 297. Do you guys remember what the word congruent meant?
Same size.
Same shape, same size. Okay, so put that down somewhere underneath of congruent, same shape, same size. Okay. Now, you can have two things that are the same shape, but not necessarily the same size. Like, for example, let's say I have a triangle here, and let's say I have a triangle here. Those are the same shape, but they're not the same size. Those are not congruent. Do you remember what they are called?
Similar.
They are similar triangles, which we will get to eventually. Those are similar triangles, but they are not congruent triangles. Okay, congruent means same shape, same size. Similar means same shape, different size. Okay, all right, so within congruent, in the whole last chapter, we talked about different things that you can do to an object and it will remain congruent. So what was one of those things that we could do to like move it around? We could translate. Translate, which means slide, like we're sliding it over. Okay, what else can we do?
Rotate.
Reflect and rotate. Okay, and if we do any one of those things or a combination of those things, it will remain congruent. Same shape, same size, okay? What's one thing that we can do that will not leave it the same shape, same size? Is a dilation. So dilations, which we have not talked about yet, or have we? Have we talked about dilations yet? What?
Probably.
No?
I don't think we have.
I don't think we have. Dilation, I'll say dilation, is for similar figures, okay? So dilating, making larger, smaller, but leaving it the same shape. So dilation is for similar objects. These three things are for congruent objects. Got it? Quit it.
This is how Wednesday.
All right, moving on. Example 1. I'm going to write some stuff down here in this bottom. We're going to fill this in down here, okay? It says, here's your instructions. We have these two objects, and these are what shape? What are those shapes called? Trapezoids. Trapezoids, okay? So we're trying to say that those two trapezoids are congruent by identifying the corresponding congruent parts. Blah. What does corresponding mean?
They're basically the same.
The ones that go together, right? Like what does A go with? W, okay? Like we're identifying which ones go together. Congruent means the same. The parts are like A and W, right? Okay? So show that the polygons are congruent by identifying all the congruent corresponding parts, okay? So the parts of this are the vertices, or let's say the angles. Let's go angles. A-N-G-L-E-S. So put a column for angles, okay? And let's do a column for sides. So we're talking about the parts of a shape. We have the angles and we have the sides. Those are what makes up the polygon, right? The angles and the sides, okay? Now we're identifying which ones are congruent to which one, okay? So I start with one object. Let's start with these guys over here. What are the names of their angles?
Angles A, C,
Angle A,
D.
angle B, angle C, angle D. This is how we're identifying them, okay? And my symbol for congruent, by the way, is an equal sign with a little squiggle over top of it. I think it's called a tilde, but don't quote me on that. I'm pretty sure it is. In Spanish, I'm pretty sure it's called a tilde. Is it called a tilde in Spanish? Yeah?
That's called a mustache.
Sure.
I don't know
Sure.
what we were.
Okay. Right.
What's approximately?
Approximately is just the squiggle, like just 2 squiggles. Yeah, that's approximately. That's like when you're rounding. Yeah. Okay, so angle A goes with angle what?
W.
A goes with W. How do I know A and W go together?
The same side.
Because they're like one little ticky mark. Okay, so angle A is congruent to angle W. So I'm finishing him down over here in this corner. Okay, B goes with angle X because they have 2 little ticky marks. Okay, C goes with angle Y, and D goes with angle Z. So we have put together the parts of the angles that are congruent to each other. Not too bad, right? Yep, and we put them in order. Okay, next, let's do the sides. So let's talk about this figure right here. Give me the name of one of the sides.
AB.
AB. Okay, that's one of the sides. We're gonna match them here in a second. Okay, what's another name of the side?
AD.
AD. Go around in a circle. AB.
Okay, fine.
BC
It's okay.
is congruent. It doesn't matter what order you go in, but to make it easier on ourselves, we'll go this way. CD and DA, or AD, it doesn't matter what you call it. Okay? All right, are you ready to know how to cheat?
Yes.
I will show you how to cheat. Okay? I don't even have to look at this figure to figure out what the sides correspond to what. Are you ready? Okay?
Just look at the.
Just look over here, right? If I'm looking at side AB, it's got to be WX. Right? Does that make sense? If I'm looking at side BC, it's got to be XY. I don't even have to look at the diagram, right? Okay? CD would be YZ. Yeah? And then DA would have to be Z. I'm going to go ZW so that we go in the same order. If we go DA, you might have written AD and put WZ, that's fine. Okay? But those are the sides. Does that make sense? Okay, that was part of the problem. It says, show that the polygons are congruent by identifying all congruent corresponding parts. These are the two sets of parts that are congruent. Angles are congruent to each other, sides are congruent to each other. And then it says, then, circle this, then write a congruence statement. Then write a congruent statement. So here's what they're wanting. A congruence statement says, polygon. Something is congruent to polygon something. Okay? So what do we want to name the first polygon?
Trapezoid 1.
Polygon
A.
A, B, C, D. We have to name it with all the letters. Polygon A, B, C, D. Is congruent to polygon. We have to go in order. W, X, Y, Z.
No way. Element of B.
Okay? You have to go in the correct order. So if A corresponds with W, you have to list those first. B corresponds to X, C goes to Y, D goes to Z. You have to put them in that order. You cannot do A, B, C, D here and go Z, Y, X, W. That does not work. Does that make sense? Because A does not go with Z. Got it? You have to go in this order. So this is what's called a congruent statement. When everything's said and done, you just write, this polygon is congruent to this polygon. Done. Got it? Good? Yes? Okay. Now, let's go to example 2. And now we're solving for things. Okay? All right. We have two triangles. This is their congruent statement. Okay? Their congruent statement that they've written is this guy right here. Circle him. Okay? Now, notice that they did not do polygon. Because what are we talking about? A triangle, so they use a little triangle symbol, so they don't have to write out the word, right? Triangle. Triangle whatever is congruent to triangle whatever. Now, this congruent statement is very powerful in that it tells me which ones go together. R goes with T. S goes with V, and then V goes with S, okay? S does not go with S, and V does not go with B. Okay, let me show you what I mean by that. So here's the deal. Do you see the two triangles that I have? Yes? Like this triangle off to the side here or this triangle off to the side here. Okay, watch this very carefully. It's pretty basic that R should go with T. Like those two angles are the same. But here's the problem. Did I flip it from here to here? Like did I just flip it over? And like basically this angle is the same as that one?
No.
Okay? Or did I rotate it around? Right? So this angle became this one.
Yeah.
Right? Do you see what I'm saying? Like I rotated it and flipped it on top. So which one did I do? Did I flip it or did I rotate it? I rotated it because this S goes with this V. That's what it tells you in the statement, right? But if there's any question, like did I flip it or which one goes with which, look at the congruent statement. This guy will tell you what goes together, right? Which ones are the same, okay? So I'm going to put that this is a 90-degree angle and this is a 90-degree angle. I'm going to map those out, okay? I'm going to put one little tick mark on R and one little tick mark on T. And then let me switch colors. Let's do 2 tick marks here and 2 tick marks here, okay? So I'm going to label that before I even look at what we're trying to solve for. This guy tells me what goes together. Got it? Now it says find the value of X and Y. All right, so let's look for X first. You see where X is? X is this little angle right here. Okay, I need to know what this angle is.
So 180 minus 90 minus 79.
I'm looking at this triangle right here. And this is labeled 78. How do you know that this one's also 78? Because they're the same, right? Okay, This one's 90. And then this one, they all three have to add up to be 180. But here's the deal. Go faster. Think smarter, not harder. We don't care about this 90 degrees. If that's already 90, then what do these two add up to be? The other 90. So I just can take 90 minus 78. Got it? What's that? 12. X is 12 degrees. Got it? Think smarter, not harder. Don't add them up and subtract from 180. Subtract those two from 90. Okay? Now the last one is y. So y is this guy right here. Do you know what 2y minus 1 is pointing to? This side right here. That's what 2y minus 1 is. So they're saying that length is 2y minus 1. Do we know anything more about that length? How long is 2y minus 1?
It's 24.
It's 24 because it matches up right here, right? So I can set that equal. Do you see how that works? 2y minus 1 equals 24. Add the 1 over. 2y equals 25, and we get 12.5 if we divide by 2, which is fine. We can get decimals. That's okay. Happy with that? Find x, find y. Good. Okay, good. Ready? Last thing. Oh, should we? No, I don't want to do that one. Okay, let's go to this one. Okay, eventually we'll get out. Do you guys remember when we did theorem sheets? Like a while back where we wrote all the stuff down? Okay. Eventually we'll get to the point where maybe I'll bring it out tomorrow. We'll write this third angles theorem down on a theorem sheet because it's kind of important. But ready for this, okay? Remington, are you listening?
Yeah.
Look at these two shapes that are underneath of the third angles theorem. Here's what third angles theorem says. Ready? C is the same measure as K. B is the same measure as J. If that is true, and we find what A is, and we find what L is, they are not marked that they are the same.
They will be.
But if two of them are marked as matching the other two, will these two end up being the same measure?
Yes.
Sure they will. Like if this is 70 and this is 50, and this is 70 and this is 50. We could subtract to find this guy and subtract to find this guy, but they will end up matching. That's what it says, the third angles theorem. Make sense? Okay? All right, let's go down to the example 3. They have a proof for it. I'm not going to write that down. But let's just talk through this. Ready? Okay? Some people are still struggling with this. When they say angle ABD, do you know which angle is angle ABD?
Yeah.
Which one?
That's like
It's the like at the end of the D line.
What is she talking about?
Am I wrong?
Angle
It's not the
ABD.
90 degrees, but it's
Oh, that's the triangle.
ABD. Which one's angle ABD?
That one.
This one, right? Yeah? That's angle ABD. He is the same as angle CBD. CBD, which is the other one. That is what we know, right? Okay, now, before we read any more, we also know that this guy is the same as this guy. How do we know that? They're both 90-degree angles, okay? So this one's matching this one, and this one's matching this one. So do A and C have to be the same? You betcha they do by the third angles theorem. Okay, so it says that BAD, which one is right here? I'm reading right here. BAD is 58. Which angle is BAD? BAD is 58 degrees. They want to know what CBD is. CBD. That's this one. Is he 58? No, he's not. What is he?
Whichever one
How do we find it?
148. It's like 32.
No,
32.
don't do that, Remington.
Well, I just did.
This is already 90. So what do these two add up to be? The other 90. Don't add them and subtract them from 180. This guy is going to be 32.
That's,
So?
I just got the same.
I don't care. You're going. You take longer. You take longer adding these two together. You took 180 minus 148. I heard you say 148. Don't do that.
How is it?
Because you're adding it to 90, and then you have to subtract one
Okay,
from
but
80.
adding and then subtracting is just as quick as...
No, it's not. As subtracting once, you're adding and subtracting. I'm just subtracting once, and that's
I'll do it my way. I'll do it my way.
No, don't, because you're wasting time. I'm trying to figure out how to shave you.
0.01 milliseconds.
I'm trying to figure out how to shave you time on the ACT, because it will.
It's like
Don't
1
do
second.
it.
It's
I don't care. That's another question that you can answer on the ACT and get another question right. I'm trying to help you. Help me help you. So what's the answer? Did we get an answer?
It's 32.
32.
32. All right, perfect. 32 degrees. Okay, good. And we're not gonna do the proof. Go and do 2 and then 4 through 12. All.
I have a question.
Yes.
Number 2. Which angles do we?
That's a good question. That's a good question. Oh, do you want to do number 4 together or no?
Yeah.
Yeah?
2 angles
Okay.
together.
Okay, number 2, let's talk about which angles go to which one. Okay? So which angle is angle L?
J.
J. So I'm gonna do one little tick mark there. I'm gonna mark on the diagram. This guy goes with this guy. Okay? Now we have to decide this bottom K right here. I'm gonna do 2 little loops. Is he? Which one is he?
ML,
Did he get
like
flipped
LMJ.
this way? Like so that he is the same as this one, or is he this one?
He's LMK because if you flip it the other way, it's
Yeah,
gonna look
he
weird.
is. He's actually rotated around. You see that? Like this guy has been rotated around. So this K goes to this M. He's been rotated around. Do you see that?
Yeah, but how do you know which ones to list in the front? Like the first. Like, do I say K to M or M to K?
Doesn't it not matter? Just
It
as
doesn't
long as
matter just
they're-
as long as the second one is the same as it.
Be quiet. At least I have a middle name and I'm not Womanian.
Like if you go LM
Womanian.
when you list, you better go JK. Does that make sense? If
Easier.
you go LM,
That just kinda
then you better say JK.
But what about L and so if I say LJ, do I have to say KM?
Why do you say LJ? Because there's no line for LJ.
No, I'm talking about angles.
Ah,
I'm talking about angles right now.
Yeah.
And then
we almost.
So you said angle L is congruent to angle J.
yes.
Okay.
And then do I say KM or what do I say?
Angle K is congruent to angle M,
I say M and K.
and angle M is congruent to angle K. I would go like that.
I never bladed.
Does that make sense?
Sure.
So like J in this triangle goes with this guy. K in this triangle goes with M down here. M in this triangle goes with K up here. Weird. Yes. Okay.
I wish they would have had different.
I know. I know. Where he's separated. Yeah, I don't like that. Okay. Should we do 4 together?
Yeah.
Yeah. We've got to list all the angles. And we have to list all the sides. That's why we're doing this one together, because it's and then we have to do our congruent statement. Ooh.
Single sides con.
Okay. Angles, sides, congruent statement. All right, angles. Let's list all the angles over here. How many angles do we have?
Wait, so how did we get 3?
How many angles do we have?
A lot.
A lot. 5A, angle B, angle C, angle D, angle E. I'm just gonna list them like that in order.
It's a lot of
E,
stuff.
congruent, congruent, congruent. I'm really terrible at that. Okay. All right, let's figure out which ones go with which. So I just went in order. A. What's A go with? A goes with F. So angle A is congruent to angle F. B goes with J. Okay. C goes with I. Yep. D goes with H. Okay. And E goes with the last one, G. Okay. All right. Now we got to do the sides.
That's crazy.
So let's name a side. What's a side? Okay, let's name AB is congruent to. Hold on. Nope, we're not labeling them yet. No, we're not labeling them yet. I'm just gonna label all the sides. AB is one side. Give me another one. BC. Okay. Next. CD. Next. DE. Next. EA.
Shut up.
Okay. Do you guys cheat?
Yes.
Yes, cheat. I didn't even look at the other
That's
diagram.
against my moral values.
Sure. If I say AB, AB is the same as FJ. Got it? BC is the same as JI. CD is the same as IH. Yeah? Do we see how this works? DE is the same as HJ. No, HG. And EA is the same as GF. Okay? All right, congruent statements. What do we call this thing?
Poly A B C D E.
Poly ABCDE is congruent to poly ABCDE FJIHG, which is not in the right order,
What?
right? If we go ABCDE, we have to go F, J, I, HG in order to be correct, right? A goes with that, B goes with that, in order for them to like be looped correctly. Yeah?
Yes.
Good?
This is
Okay, that's it.
What was the,
Woo!
what was number two?
What?
What was number two? That's it?
This is angles. Then you gotta do the rest of them.
Oh, gotcha.
You gotta do the sides as well, and you gotta do the congruent statement.
Wait, do you have to have K, M, and N, K?
Oh,
Yes.
no, we have to do it
Yes.
for number 5 as well.
Wait.
Yep.
Yeah, we're not done with number 2. But
So 2 and 5. And then the rest of them are solving things.
angles and sides
Okay?
and
Good?
congruent statement.
I wouldn't
You betcha.
have a problem with this lesson if it didn't take the best years of my life.
Anything else before I stop recording? Are we good to go? Alright, goodbye people watching this.